Okay, so today we're going to talk about parallel lines. The definition of parallel lines are lines that are coplanar and do not intersect. These lines will go on forever and ever in both directions and will never intersect. Other types of lines that do not intersect are called skew lines. Skew lines are lines that are non-coplanar and do not intersect. The difference between parallel lines and skew lines is that while both do not intersect, parallel lines are coplanar, skew lines are not coplanar. Parallel planes are planes that do not intersect. Just like parallel lines are lines that do not intersect, parallel planes are planes that do not intersect. First theorem in this section: if two parallel planes are intersected by a third plane, then the lines of intersection are parallel. Remember that if two planes intersect, their intersection is a line, and so this theorem is saying that if the same plane intersects two parallel planes, those intersection lines will also be parallel. Some types of special angle pairs. Okay, we want to think about alternate interior angles as angles that are on in between two lines, but on alternating sides of a transversal. Okay, so let's define this word transversal. Transversal is a line that crosses two lines. Okay, so in my diagram over here, we're going to consider the two lines to be the red lines here, and the transversal to be this green line here. So if we're talking about alternate interior angles, we want angles that are in between the red lines, but on alternating sides of this green line. So the two pairs of alternate interior angles would be angle 3, and then on the other side of the transversal, angle 6. And the other pair would be angle 4 and angle 5. Angle 4 and angle 5 are in between the red lines, but on alternating sides of the green line. Okay, now, same side interior angles. Alternate interior angles are in between the two lines, but on alternating sides of the transversal. Same side interior angles are still on the interior, but we want on the same side of the transversal. So same side interior angles, for instance, would be angle 3 and angle 5. And also angle 4 and angle 6. Notice angle 4 and angle 6 are in between the red lines on the interior, and they're on the same side of this transversal. Corresponding angles are angles that are in the same relative position to the lines in the transversal. So for instance, if we look at angle 2, notice how angle 2 is in the upper right-hand corner of this intersection of red and green. The angle in the upper right-hand corner, in other words, above the red line to the right of the green line, above the red line to the right of the green line, would be angle 6. So angle 2 and angle 6. Similarly, notice angle 4 is below the red line to the right of the green line. Below the red line to the right of the green line would be angle 7. So angle 4 corresponds to angle 7. And similarly, angle 1 corresponds to angle 5. Angle 3 corresponds to angle 8. Okay, in this exercise, we want to name the two lines in the transversal that form each pair of angles. Then we'll classify the angles as alternate interior, same side, or corresponding. Now, I think the easiest way to do problems like this is to trace each of the angles, decide the transversal first, and then get the other two lines. So angle 5 is right here. There's angle 5. Angle 6 is down here. And I think the easiest thing to spot first would be the transversal. The transversal is the line that helps form a side of each angle. So the transversal touches both angles. That would be this right here. The transversal would be this segment, DF. I'm going to circle the transversal. And then the other two lines are simply the other side of each angle. So the other side of this angle would be DG. The other side of this angle would be EF. And we notice that angle 5 and angle 6 are on the interior of these two lines, but on alternating sides of this line, the transversal, so these would be alternate interior angles. All right, example 2, angle 8 is right here. Angle DGF, so DGF is right here. Okay, so we can see that the transversal is this segment that touches both of the angles, GF. And the other two sides, well, this side, the other angle is formed by this side, DG. And this angle's other side is formed by this segment, FI. And angle 8 and angle DGF are right here and right here. We can see they are on the interior of these two lines, but on alternating sides of this transversal, so these are also alternate interior. Okay, the next example, angle 3 and angle GDH. Angle 3 is right here. Angle GDH is right here. We look for the transversal, which is the side that touches both angles. That would be this guy here, so DH. And the other two sides are just the other two sides of each angle. So this side here, DG. And this side down here, EF. Okay, so we're talking about this angle here and this angle down here. This angle is below the line and to the right of the transversal, below the line and to the right of the transversal, so in the same relative position, so we call those corresponding. Okay, angle GDE and DEF, well GDE is here again. DEF would be this guy. Okay, so the transversal is the same, DE, touches both sides, both angles. And the other two sides are DG and down here, EF. Talk about this angle and this angle. These angles are on the interior of the two lines, but on the same side of the transversal, so we would call these same side interior. I'll save the remaining 4 examples for you to try, and there's a homework assignment. And that's the end of the lesson.